Hello, and good afternoon. My name is Aaron Creech, and I am a Solid Edge Application Engineer with PROLIM, located in Cincinnati, Ohio. Today we'll be discussing advanced sheet metal updates for Solid Edge 2020. For this webinar, we will talk about sheet metal terminology, different sheet metal environments, new features to the sheet metal portfolio, particular lofted flange enhancements in way of vertex mapping, bend methods, and new bend table features. We'll also look at the new Bend Bulge Relief function, all while using the rapid design process. Now let's quickly go over some commonly used terminology within the solid edge sheet metal environment. We'll look at the 7 most commonly used terms. Number 1 is your plate or base feature, which is the origin for the part, your sheet metal part. All your other features and geometry will be derived from this part. It's also going to be the origin for your flat pattern when we get to create that. Number 2 is your tab or your flange. And these are just simply two flanges or plates that are connected by a bend, which connects 2 tab flanges together. Your bend relief, which is the option to prevent any tearing or deformations during the bending procedure. And then you have your cutouts, which are any openings within the part. Then you have your corner, where 2 or 3 bends meet together. And then you have procedural features, which are deformations such as dimples, cutouts, louvers, beads, and gussets. And we'll get into those a little deeper in this webinar. Now let's briefly discuss the different sheet metal environments. Currently, Solid Edge has 2 different sheet metal environments. We have your synchronous environment and your ordered environment. Both offer unique advantages and benefits, but we'll look at each one of these individually. Synchronous environment is more of an object action. And what that means is you need some sort of geometry, existing geometry or part information in the file in order to enact some of the commands. As you can see from the top image, all of our sheet metal commands are grayed out at this time. This is because it's a brand new part and there isn't any information in the file yet. In the ordered environment, we have what's considered an action object functionality. So that means that you can enact the certain commands that you want to generate the part. So we have the ability to kind of go back and forth between these environments. So if you're more of a synchronous user, but there are a few commands that are only in the ordered environment, you can quickly migrate over to the ordered environment, make your changes or create these custom commands, and then you can quickly migrate back to your more comfortable environment. So we have the ability on the fly to switch between synchronous and ordered at any time to get access to all of the commands. Unfortunately, we just have to do that in 2 different environments at this time. So we're going to look at the lofted flange in particular, and this is going to require us to be in the ordered environment or the action object. And then we'll go through a few of the steps to create these processes, and you can see the difference between the 2. Now let's go ahead and open up Solid Edge and see these new commands in action. Okay, first thing we're going to look at is vertex mapping. In order to get to the vertex mapping, we're going to have to create a lofted flange. So I've got 2 simple sketches here created, and we're going to real quickly create a lofted flange based on this existing geometry. Select my first sketch, select my second sketch. Now you can see we quickly generated a lofted flange. Pretty simple part. Took me just a couple of seconds to create this part. But you can see that if we look at it a little closer, we really didn't get the desired effect. If we look at the top view here, we can see that everything's kind of going from left to right. Everything's kind of swinging in this direction here. So what we're going to do is we're going to go in and adjust this vertex mapping. It defaulted to just the quickest, simplest resolution to the part. We can even see we've got a little oddity of a relief here on this side that doesn't exist on this side. So we're going to want to real quickly go in and change this. So it's pretty simple. We just edit our definition. Now this is our new vertex mapping icon. So we can select this. It's going to bring us to our vertex mapping dialog box, or we can add a couple of new sets. So set 1 is your default set. We can't delete this or change this. We just kind of have to deal with it for now. But we can add some additional sets to give us our desired result. So it's pretty simple. We just select add. We're going to just start clicking here. We're going to give it some more direction, a little bit more information. Okay, pretty simple. We'll hit OK. It'll recalculate the part. And now you can see that if we look at the top view, now we're much more symmetrical. All the angles are kind of going in the right direction, all towards the center of the part. It got rid of the little auto relief that we had over here that didn't match the other side. So it gave us the desired result within just a few quick seconds. So let's go ahead and look at this option here a little closer. So now we have the auto relief feature. So if we go back into our edit definition, we look at our options, we can see that we have the ability to change this auto relief from either linear to spherical. Currently we're on linear. Let's go ahead and change it to spherical so we can kind of see what type of control we can add here. And it just simply reselects it. You can see now it gives us a much more kind of an open, if you will. And depending on the process, the manufacturing process, you can see there are little different sizes based on the positioning of the angles and bends required. So Solid Edge is really taking a really good step here to make these features just super simple to use. So as I mentioned, just within a very short few minutes, we were able to complete the part. We're able to adjust it to give us a desired result, and we were able to go in a step further and even give us even more control over the part. So that's the Vertex mapping. Again, pretty simple. Now let's jump into the bend methods option within the Lofted Flange command. I've already generated another file here with a couple of simple sketches, so we're going to go ahead and do another simple lofted flange. This one's going to have a little different shape to it, but the method is still the same. So now you can see we've got this kind of a complex part, very easy to design, but unfortunately this is going to take some time and some effort to manufacture this part as is. So right now, with traditional bending methods, there's no way we could bend this in this shape with traditional methods. We would need some sort of customized die tool to get this bend. So we want to get this part to be a little bit more of a practical manufacturing part. So in order to do that, we're going to have to create some additional bend steps. So let's go ahead and look at this part a little deeper. So we're going to go ahead and just create a quick flat pattern of this part so you can kind of tell the difference between the different options here. Simple flat pattern. As you can see, we've got our two bend lines here. So let's go ahead and save this file, revert back to our flange, and now we're going to just create a sketch or a drawing file from this part. Draw from active model. Give it a second here. Now we're going to go into our drawing wizard or view wizard. We're going to select a flat pattern view. Okay. Change the scale here a little bit. There we go. Okay, so as you can see, we've got just two bend center lines here, and to reference for manufacturing purposes. Unfortunately, as I said, with traditional bending methods, this really isn't going to give us our designed result here if we just bend with a traditional press brake using these center lines. So let's go ahead and go back into our model again. We're going to do an edit definition. And now we're going to look at this new bending methods tab that's new to Solid Edge 2020. So again, as mentioned previously, this part was kind of just built using the traditional default settings. So now we have the ability to go in and add some additional features to give us a much more desired effect. So within this new bending methods, we now can control the triangulation of each one of these bends. So as I mentioned, in order to get this to a more practical manufacturing part, we're going to have to add in a bunch of additional bend lines here. So let's go ahead and explore these. So we're going to go ahead and select the use triangulation to develop each bend. And now we have two options here. We can choose to show the bend lines, or we can choose to show the actual bends themselves. So let's go ahead and just select bends. Now, as you can see here, we have a couple of options here that, depending on which selection we choose, we have control over. So we're actually going to go ahead and change the bends, and then we're going to select the number of segments in arc. So essentially, this is going to allow us to select the number of actual hit points along this bend to create our desired effect. We'll go ahead and select 10 for this example. Okay. And you can quickly see that it adds the actual bends themselves into the steps of the bend, that overall bend radius. So if we finish this, jump back into our draft file, you can see that our view is out of date. So we'll go ahead and update our drawing view. And it rotated on me there, but move it. But as you can see, now we have bend lines in there that are more practical to use with traditional bending methods, and brake operators now have visuals to where each one of their reference lines are to generate the step-by-step bends to create that overall bend that we're looking for. So if we go back into our model again, we'll dig into the other option here. Go back into our options, bend methods. And now we're going to look at the actual bend line representation. So we can select that. And now with the bend line, we now have the ability to even add index mark lengths. And just to confirm, the index marks are only written in the DXF file. So even though you're selecting to do index marks within 1/4 of an inch from the edge of the part, these are all going to be represented on the file that you send down to the production team. So they won't be present in the physical model itself. So it's a good point to understand. So now we're going to go ahead and do bend lines, and we're going to just generate the same number here. We're not going to change any of the chord heights, segment lengths, or segment angle. Although we do have the ability to go in and change any of those as we see fit. Let's go ahead and do that. So now you can see that the actual physical bend lines have now been changed to represent the bend center line. So again, those are just representations of where the bends will happen. They're not on the physical geometry of the part. And again, if we go over to our draft file, update our view one more time. And now you can see we have additional bend lines here that we can physically reference. And again, in the DXF file, you will have some, if you chose to show the index marks, they would be in this area. Just reference points that the brake operator can use if he doesn't have the CAD system or the ability to reference these actual draft files. The DXF file will suffice for that. There's one final feature enhancement with the bend methods within the Lofted Flange option that I'd like to briefly hit on. There's been a new Included Lofted Flange bend lines option on the bend table dialog box, which includes the triangulation hit lines, which means the bends are treated individually and included as entry for each one of the bends in the table. If you clear this option, the Lofted Flange will have only one bend listed on the bend table. So let's go ahead and look at that. Go to our Tools tab here and go ahead and activate our bend table. So as done in the previous step here, we were able to generate the Include Lofted Flange bend lines. But one improvement to the actual bend table itself is the ability to either toggle this off or on in order to kind of show us the pertinent information that we require. So if we were to unselect this, now we go back down to just the two bend sequences here. So we can highlight them here, sequence 1, sequence 2. But with the new additional feature here to include the Lofted Flange bend lines, we can take this just two 86 degree angle bends and include those steps in order to achieve this with traditional manufacturing methods. So as you can see, now it's taken those two bend regions and converted them into the 12 sequences that we need to generate that profile. In each one of those, the angles have updated as well. So a very cool feature here, and we also have the ability to go in and change the sequences here if we need to. We can highlight bend sequence number 3 and move it up or down. I'll go ahead and cancel this. And then we're going to jump right back into the draft, update our file, and now we're going to generate the actual bend table for the draft itself. Let's move this over a little, make us some room, and now we're going to bring in that bend table. Select our drawing. And as you can see, now we have the bend table with all 12 sequences in there, giving us the additional required information that we need to generate this profile. Again, we need to adjust these. We have the ability to go in and adjust them on the fly. Just some additional information here. So again, as the software is being improved in the modeling environment, it's also being improved on in the drafting environment, as well as the variable features or tables are also being updated. So all very good changes here. And lastly, we're going to look at the new addition to the Bend Bulge Relief command. So we're going to simply just create a new sheet metal part using the rapid design process here. We're just going to create a simple little bracket. Go into our contour flange. We're just going to create a contour flange. And just replicate a simple little, maybe aluminum bracket here. Close our sketch. Confirm our direction of material. The width of the part, we'll say it's 100 millimeters. And now we've just got a simple little part here, and we'll add one additional flange to the right side of the part. And we're going to change this to just a small tab. And again, we're just going to kind of use some existing geometry to place it. And once we've placed it, we do have the ability to go in and make some final adjustments to it. So let's just say we want this tab to be 50 millimeters. And maybe it's at a 120-degree angle. So no problem there. We'll go ahead and finish that. So within less than a minute, we were able to create a pretty simple part here within sheet metal. And now this command, the Bend Bulge Relief command, is probably more typical for a part that's thicker in nature. So when you're dealing with maybe some more thicker gauge materials, we're going to go ahead and adjust this to give the part a little bit more meat. And once we're in our material table, we can navigate to the gauge properties. Let's go ahead and change this to maybe, it's set to 1 millimeter thickness. Let's go ahead and change this to maybe 3/8 of an inch. And again, we can just specify inch even though we're in millimeter units. Go ahead and hit apply to material. And you can see that now we've got a really thick, small part that probably would cause some type of bulging or other issues while bending this part. So this is where this new feature will really come in handy. So let's go ahead and go to our bend, pull down, and go ahead and select our new Bend Bulge Relief function. And go to the options, and we have 3 different types that we can select from: circular, U-shaped, and V-shaped. As you can see, each one of these have kind of a visual indicator and along with the types of adjustments you can make to it. Let's just keep it simple for now, and we'll just select circle. And we'll go ahead and just leave the parameter, the relief width and depth at 3.254 millimeters, whatever the default is here. Go ahead and hit OK. And now it's asking us to go ahead and select the bends to apply the relief. So we can select any of these bends, and you can see it automatically applies the relief based on the parameters that we set. So based on that kind of visual there, I think we probably need to go a little deeper. So let's go ahead and change this to maybe 6 millimeters, 2 millimeters. Okay, and you can see we're getting a more kind of realistic, and actually maybe we want to bump that up just a little bit more. We'll give it, let's go 10 and 5. There we go. That's more realistic for that thickness of material. So again, we can select those individually. Let's cancel this. Show you one other option here. So we can also go back in here, select cylindrical. We'll leave the parameters the same. Now, if we select the S key, so we'll select this guy first, and now we'll hit S. So what this is going to do is it's going to locate all of the like or similar bend radiuses and select them all at once. So that's kind of a handy little tool. Let's go ahead and click cancel one more time, and we'll go back into it one additional time. Hit OK. Now this time we're going to hit A for all. This actually goes in and selects every single possible corner that would require relief. So let's go ahead and accept that. Okay, and now we've got the Bend Bulge Relief for a part that would probably give us some tearing or some bulging issues during the actual bending process. So if we want to take this one step further and kind of just look at it a little deeper, we'll go ahead and just really quickly generate a flat pattern. I think these are more, you get a better understanding of it when you look at it in a flat pattern. So there you can see, very quick and easy way to create some reliefs. It's all about creating a very workable part for your manufacturing team. You don't want them to be fighting on it simply because it was easy for you to design. You always got to think about that downriver process and who is going to take your project and then create it into a real functioning part. And based on experience, you never want to be upsetting the people in the manufacturing environment, just to kind of keep that positivity going. In closing, we discussed and demoed the latest additions in the sheet metal environment for Solid Edge 2020. We looked at the Lofted Flange enhancements and new Bend Bulge Relief command and how easy and quickly it is to take advantage of the added controls for your sheet metal designs. At this time, we'll open it up for any questions that you may have based on this webinar information. If there are no questions, please save my contact information for future questions if you may have them. Thank you very much for attending.